Good morning. Sorry about that. So hopefully you've already downloaded this PDF, although I guess if you're going in order, you're watching this video first. So the next thing will be to download this PDF so you have a nice template from now on to make graphs, and then you can use this to help you study. I wanted to go over one of the groups. So I apologize to Alex and Kaylin's team that I'm doing Josh and Emma's team's graph, but it's very similar. And so we talked the other day in the warm-up about how would we make this a whole number. And so here's the deal, you guys. This chapter is all about graphing. And anytime in math, forever and ever, whenever a teacher gives you an equation, okay, like this, and they say graph it, you may choose lots and lots and lots of different numbers for the input, okay? And then you do the math and you'll get an output. That's called an ordered pair because they go together. Whatever you input for X is going to determine what the output is for Y. And so, you know, we could pick any number, really. Some of them aren't going to work because it's a square root, but we really could choose any number for X. But let's choose wisely. So that's what I want to talk about today. First of all, is let's choose wisely, as well as what is this graph of a square root going to look like. And so if I want to choose wisely, since Mrs. Pierce isn't letting you use a calculator, I want to try to find numbers for X that will make this end up being a whole number, okay? I say whole number because they're not going to be negative, so it's got to be a whole number. So, you know, in your toolkits, you should have made a chart of perfect squares. So perfect squares would be 0, 1, 4, 9, 16, and I could go on forever. And I got these numbers over here because 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And they're called perfect squares because if we take the square root of these numbers over here, we're going to get a whole number or an integer, okay? So looking at this square root part here, I'm thinking, what could I replace X with so I end up with 0? And that's 1. So if I put 1 in for X, and then I go do the math, 1 minus 1 is 0, the square root of 0 is 0, add 3, and we get 3. Okay, the next perfect square over here is 1. So what number could I put here that's going to give me 1 when I subtract 1? And that's going to be 2. So if X is 2, 2 minus 1 is 1, which is what we wanted. Square root of 1 is 1. And then add 3, and we get 4. Again, guys, math, it's all about understanding math and understanding numbers and being able to manipulate things so that it turns out pretty for us. So now my next perfect square is 4. So what could we put in for X that I will get 4 after I subtract 1? Well, that'd be 5. So if I replace X with 5, and then 5 minus 1 is 4, which is what we wanted. The square root of 4 is 2. Add 3, and we actually get 5. Let's try to get 9. So what could I put in here to get 9? That would be 10, because 10 minus 1 is 9. Square root of 9 is 3. Add 3, and we get 6. So I plugged in 9, and I got 6, I believe, right? Yep. I'm sorry, we didn't plug in 9. We plugged in 10 because we wanted to get 9. So remember, we plugged in 10, subtracted 1, got 9, take the square root, got 3, add 3, and got 6. Now, I'm going to leave it at that for right now. If we had used 0 here, right, 0 minus 1 is negative 1, and we can't take the square root of a negative number because it won't be a real number, okay? If you tried to do it in a calculator, it's going to give you a domain error or some kind of error symbol. So whenever I take the square root of a number, it has to be a positive number underneath here, at least for Algebra 1. When you get to Algebra 2, I'll give you some more strategies. So let's graph. Okay, let's see if I can graph nice and neatly. Let's see here. Okay. A student taught me this once. All right, so I'm going to graph the point 1, 3. So 1, 1, 2, 3. There we go. Let's duplicate that. And then I'm going to graph the point 2, 4, 1, 2, 3, 4. Okay, duplicate that point. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And duplicate again. And I think it's going to fit 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to estimate where 10 would be so that I can go up to 6. Okay, now we said that this looks weird, I know, and if you don't know what a square root graph should look like, you're probably like, what is going on? So that's why I made this video for you, since we don't really have a lot of time today. 1 was the smallest number that we could use, because if we chose anything less than 1, we would have gotten an imaginary number. So that means that this point right here is my starting point. I can't choose any other numbers to the left of it, so it's actually starting here. It is going to go on forever, but do you see how it kind of like, it starts to curve off, okay? So it sort of looks like a sideways parabola. And that's kind of what square roots look like. Square roots look like a sideways parabola, but only half of it, because we can't have the negative parts underneath. So that's what this one should look like. Just FYI, all square roots should look something like this. Let me try making that a little bit prettier. So all square roots should look something like this, sort of like half of a sideways parabola. It could be upside down, it could go to the left if you have negatives in different places, but that's kind of the gist of what a square root should look like, okay? All right, so for tonight's homework, all you need to do now is fill out the x-intercepts. In this case, there isn't any. The y-intercepts, in this case, there isn't any. Line of symmetry, you don't have to do that. And a vertex or starting point. So we do have a starting point. And the starting point for this looks like it's 1, 3, and this is my starting point. So that's what you need to fill out tonight, okay? All right, let's go down here and talk about this graph. I hope that you know this one should be a line, because it's not x squared. There's no square root, there's no radical sign. This is like you should have done a lot in 7th grade. You should have graphed a lot of equations like this, and they would have been lines. So I want to talk about, again, you can't use a calculator. I don't really want to deal with fractions on my graph if I don't need to. So let's find pretty numbers. So just like we did up above, what numbers could we replace x with so that when I multiply by 1/4, we get an integer out? Well, since the denominator is 4 that I'm multiplying by, I want to choose multiples of 4. So if I choose multiples of 4 for x, this is going to turn out pretty, okay? We can use negative numbers, which is what I would suggest, and we can also use 0, because anything times 0 is 0. So let's start with 0. 0 times 1/4, that's 0. Minus 3 is -3. So that turns out pretty for us. And then if we try 4, 1/4 times 4, right, those 4's cancel out, is just 1. And then 1 minus 3 is -2. Okay, let's try 8. 1/4 times 8. 4 goes into 8 2 times, and then 1 times 2 is 2. And then 2 take away 3 is -1. Okay, now 12 isn't going to fit on my graph, so let's go into negatives. So let's try -4. And so -4 times 1/4, the 4's cancel, but now we have a -1, and -1 minus 3 is -4. And then let's try -8. So again, you guys get to choose what numbers you use. If you use just 1, 2, 3, 4, 5, you're going to have some fractions, and it's just going to be annoying to graph. So you need to now use your brains and think about, what would be some nice, pretty numbers to plug in. So if I did -8 times 1/4, 8 divided by 4 is 2, so it's really negative 2 times 1 is negative 2, minus 3 is negative 5, and I'm just going to stop there, okay? I'm graphing a line. It should look like a line. And so let's graph these points. I'll use my trick that my student taught me once. Okay, so 0, negative 3, 1, 2, 3. And then 4, 1, 2, 3, 4, negative, oops, 1, 2, 3, 4, negative 2. And then, oops, duplicate, 8, so 4, 5, 6, 7, 8, negative 1. If you know how to graph this using the slope and the y-intercept, hey, that is fantastic. You may gladly do that. Negative 1, 2, 3, 4, negative 1, 2, 3, oops, 4, and one more time. This one should be over here. Okay, so I've got a graph. It's a line, and when I draw a line, I'm going to try to be as neat as I can here. Okay. There we go. I've got arrows on the end. There's my graph. Now, I did not make this a complete graph, right? So here's my axes. This is the y-axis. This is the x-axis. I'm going to do my scale. 1, 2, 3, 4. So here's 5. Here's 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 5. 1, 2, 3, 4. Negative 5. Okay. So, and then my equation, I can actually duplicate this as well if I want to. Put that right here. And now I have a complete graph. My x-intercept, I don't know what that is yet. I'm going to leave that blank for right now. But my y-intercept is the point 0, negative 3. We don't have a vertex. We don't have a starting point, so we don't have any of those as well. Okay? Really quick, because I feel like I need to go up here and make sure I have a complete graph. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4. Negative 5. 1, 2, 3, 4. Negative 5. 1, 2, 3, 4, 5. Y-axis. Oops. X-axis. I've got my arrows. Let's copy my okay. So hopefully this wasn't too long, but hopefully it helped with some of the questions you guys had last night. I'm not going to go over the cubed root graph. I will go over that with you guys on Monday. If you have any questions, I will see you guys, I think I said at 9:45. Okay, see ya.